Yes, class. Am I audible? Humam and Shahid?
Yes, ma'am.
All right. So we have completed the lesson in the last class. Electric potential and capacitance. You already had the exam also yesterday. I haven't seen your copies. I'll receive it and I'll then share it, the scores with you. Now, C class, regarding your third lesson, this is electric current. Current electricity, when we are referring to current electricity, see, till the time we were discussing about electric potential, electric charges and field, till that time, all the charges were at rest. All the charges which you had, all the charges were at rest. We weren't talking about the terms like acceleration, velocity for any of the charge. So when the charges begin their motion, we call it as rate of change of flow of charge, which is known as electric current. Now you are free to talk about the movement of charges. You are allowed to talk about the acceleration, velocity. You can apply the equations of motions. Everything is up to you. Fine. Now, electric current is what? Current is basically rate of flow of charges. Rate, whenever I use the term rate, I have discussed this before also with you all, that whenever rate term comes, rate means something is getting changed with respect to time, or something is getting divided by time. Like here, suppose this is a wire. Wire means a normal conducting wire I have taken this wire, fine? This segment of the wire I'm talking about. So charges must be flowing through this wire. Let's say charge Q is flowing across this wire. This is some initial time and the charges have flown and I have stopped the time at T. I have stopped the timer at T. So some amount of charges must have flown when this T, during this T amount. So that electric current, we represent it through I. In class 11th, you study this in your dimension analysis, that current is represented through I, charge per unit time. That's it. Charge per unit time. Q is what? Q is the charge. T is the time. Charge per unit time. Now, tell me one thing. At T is equal to 1 second. If I put T's value as 1 second, what would the equation now be?
I is equal to
How much, Chavez?
I is equal to Q.
Exactly. I is equal to Q. See, if I put time as 1, the denominator, if I make it as 1, what will I get? I'll get current is equal to the charge, right? So current is equal to the charge in this. So what is another definition of charge or definition of current which you can apply? So definition of current is basically, you can say amount of charges that have flown, for a duration of 1 second. Amount of charges that have flown for a duration of 1 second. This is what is meant by it. Now, SI unit of current is what? SI unit is amperes. Represented by capital A. So you will be seeing this like 5 microamperes of current, or current is equal to 3 ampere, current is equal to 3 nanoamperes. Like this, you will be seeing the units of it. Now, it's a scalar quantity, as in when I am writing, it's a scalar quantity. So what are scalar quantities? What are vector quantities? So you have already studied this in your class 11th. Scalar quantities are those which have their magnitude, right? And no direction is present. Vector quantities are those which have the magnitude, they have the direction, as well as they obey the vector laws. So why do we put current as scalar? Remember one thing, current, electric current, whenever we are talking about this quantity electric current also has its direction. All right, when we are talking about electric current is also having its particular direction. So still, even after we have the direction of electric current, we are still placing it under the category of scalar charges, scalar quantities. The reason behind is that It has the magnitude. It has the direction. So it should be vector? No. Reason? It doesn't obey the vector laws. If I give you a situation and I ask you to calculate the net current, you'll not be able to find it using your parallelogram law, your triangle law, your polygon law, all the laws which you have studied, because electric current doesn't obey all the vector laws which you have studied. That's why we keep it under the category of scalar charge, because even if one of the criteria is not fulfilled, we change it, right? So electric current, it has a direction. Direction we'll see. I'll tell you the direction right now only. But it is considered under scalar because vector laws are not obeyed. That's it, what is meant by electric charge. These are the basics of it. Just remember the direction. See, if you are having a positive set of charges, suppose I'm having this charge plus Q. Let's say this charge plus Q, this is moving towards the right with V velocity. What will happen to the direction of electric current? See, when we are saying the direction of charges towards the right, current is along the same direction for positive charges. If velocity of the charge is moving towards the right, current will also move towards the right. But suppose, let's say if this is a negative charge and this negative charge is moving towards the right with some V velocity, now we have to reverse the direction of current. Current's direction will be like this. So always remember, in the question, wherever you will be having particles, elementary particles like electrons, you have to reverse the direction. Calculate it the way you have to, calculate the way you have been calculating it. At the end, just reverse the direction. That's it, what you have to remember regarding the direction. Otherwise, no such specific rules you have right now, right-hand thumb rule and all will come under magnetics only in the next lesson. So whenever charges are flowing, direction of current is same for positive charges and opposite for negative charges. If the charges are moving, suppose the electrons are moving, let's say downwards, electric current will move towards upwards like this. Now, before we move on to the numericals part regarding this, just note down these basic quantities. You had your maths class, no, on Wednesday. That's why we had to shift one class here, because on Saturday your maths class got cancelled. That's why we are having this. This is not extra class. This is just class of Wednesday, which was postponed. See how to use this formula. I is equal to Q divided by T. Some of you had this class earlier, but that time we had to rush it up. Now we'll do it in detail. See, whenever you have a particular time duration, suppose 0 to 8 seconds, 0 to 2 seconds, 8 to 9 seconds, or a particular time is given 2 p.m. to 4 p.m., 3 p.m. to 9 p.m. Like this, you have a duration where there is an initial time and there is a final time. In that case, how do you calculate? Current becomes change in charge divided by change in time. We had seen the formula, no, right now, charge by time. I is equal to Q by T. So here, the difference in the charge divided by the difference in the time. This is the formula. How will you use? So how will we calculate change in charge? Final charge minus original charge. Final charge minus initial charge. Similarly, here also for time duration also, final time minus initial time. This is how we'll put. What is this called? Whenever you are calculating this, this is used in your velocity acceleration also. In class 11th, you must have done this. This is average current. The value of current is average current. Then this is one case where we calculate the average current. If I give you a particular time instant, let's say 0.001 seconds, 0.8 seconds, 3.1 seconds, 3.0006 seconds, or tell me the current exactly at 2 p.m., tell me the current exactly at 2:13, like this. If I tell you a very particular time instant I'm giving you, where there is no initial time, there is no final time, it is just an instant of time which I am giving. In those cases, we calculate differentiation of charge, means change in charge with respect to time. And the type of current which we obtain now, this is known as instantaneous current. So you have to identify well whether you are calculating instantaneous current or you are calculating average current. Now we'll see some questions, one or two questions based upon this before starting with drift velocity. Note down this part, then we'll do one question. See, this question says that charge is flowing through cross section of a conductor Q is equal to 3t square plus 2t plus 1. So this question, I think Rabia and Austin, you have seen, we had discussed this type of question in the class. Others, see, first part is saying current in 0 to 2 seconds. And second part is asking current at t is equal to 2 seconds. So that is what we were discussing. When it is 0 to 2 seconds, that's a particular duration, time duration for you. So in the first part, I is equal to change in charge divided by change in time. That is final charge minus initial charge divided by final time minus initial time. This is how we have to calculate. What is the value of final charge? Put the final time. Put the time as 2. This is the final time. No, initial time is 0. Final time is 2. So put the value of final time. Q as the final time. So 3 instead of 2, I will put 2. Instead of t, I will put 2. So that becomes 2 square plus 2 into t. That is 2 into 2 plus 1. That becomes 12 plus 4. Then 16, 1, 17. This is 17 coulombs, right? Nextly, for the initial charge. For the value of initial charge, now I will put charge as 0, time as 0, because final charge is at final time. So initial charge will be at initial time. So 3 into 0 square plus 2 into 0 plus 1. That is 1 coulomb only. What is the final time? Final time is 2 seconds. Initial time is 0 seconds. This is what is given. 0 to 2. So final charge is 17 minus initial charge is 1. Final time is 2 minus 0. So 16 divided by 2, which is 8 amperes. This is the answer which you are getting when we are calculating current between 0 to 2 seconds. If we have to find out, yes.
Ma'am, here we don't have to differentiate to find.
No. Here you don't have to differentiate because we are calculating the average current. 8 ampere is the average current. Here you won't differentiate. But see, in the second part, it is asking you the instantaneous current because exactly at a particular instant you are asked. Now you will differentiate. At what time? T is equal to 2 seconds. Because now we are no more calculating average. We are calculating the instantaneous current. So Q is equal to 3t square plus 2t plus 1. See, on differentiation, dq over dt. 3 is a constant. X to the power n becomes nx to the power n minus 1. So 2t to the power 2 minus 1, right? Plus 2 t to the power 1 minus 1 plus constant. Whenever you differentiate a constant term, you always get a 0. So what is the equation of current that we have obtained? 6t plus 2. Now this is the equation of current which you have obtained, but still you haven't substituted the time. So we have to properly substitute the time. So at t is equal to 2 seconds, current will be 6 into 2 plus 2. That is 12 plus 2, which is 14 amperes. See, difference between the instantaneous current and the average current. Average current was 8 amperes. This is coming out to be 14 amperes. There's a difference between both the values of current. Quickly note it down. One more question we'll do based on this. Next, this question says that an electron is revolving around the nucleus with the frequency nu. Calculate the current. See this concept regarding frequency of electrons and nucleus. You have this in your second book also. Nuclei is there. You have atoms and dual nature of matter and radiation. There you study this in detail. So that's why this question is there. But one thing I'll tell you, frequency is inverse of time and time is inverse of frequency. Frequency is actually 1 by time period. What have we studied regarding charge? Charge is current is charge divided by time. Tarif has joined. Tarif, when is your exam? When is your exam?
14th.
14th. So magnetics and nuclei are the extra lessons, no, which are coming?
Yes, miss.
Okay, I'll inform you about the class. Fine. I hope you'll be able to join, no? If
Yes,
I
miss.
just take your separate class. Take. So, okay. And regarding the charge, since this is mentioned electron, so how can you convert charge into electron? Ne. This is quantization of charge. When we had begun our class, we had discussed quantization of charge. Quantization of charges. Quantization of charges means that charges are integral multiple of this one electronic charges value, which is 1.6 into 10 to the power minus 19 coulomb. So one electron has this much amount of charge. So n number of electrons will have n amount of charges, right? N multiplied by this amount of charge. That is quantization of charge. So when we put the value here in electric current, that becomes Ne divided by T. And class, we do not have to write our answer in terms of time. We cannot write our answers in terms of charge because in your question, neither charge is given nor time is mentioned. What all quantities we have? We have electron. So that's why we had converted the charge into electron. And secondly, we have the frequency. So how can we convert frequency? 1 by time period, you can write it as frequency. Look here. Can I write I is equal to Ne multiplied by 1 by T? Right, this is the same thing. And what is 1 by T? 1 by T is actually this. So this term also you can replace it and you can write it as frequency. So your final answer I will become Ne into frequency. This is frequency. Just understand this relation for the time being. This relation, you have this in your syllabus. So there we discuss. Note it down. After this, we'll start with drift velocity. Coming to drift velocity, what is meant by drift velocity? So velocity, you all understand what is the meaning of the term velocity. Velocity is rate of flow of distance, rate of change of distance. That is velocity. But here we are referring to drift velocity. Why are we referring to drift velocity? See, when we are talking about a conductor, if we are having a segment of wire, under the wire, under the surface of the wire, you have positive ions also, you have negative electrons also, negative charges are present, negative ions are present. All the contents are present, right? Not only you just have one single electron which is moving, you have so many electrons which are moving. So if I ask you what is the velocity of the electron, the particular electron which is moving, will you be able to tell me one particular electron which will be solely responsible to conduction, to the process of conduction? You will not be able to answer that question. Why? Because there is not a single electron which is present within the wire. Every electron is present and each electron is moving with its particular velocity. So when we take that average velocity of all the electrons with which they are moving, which with they are drifting towards the positive terminal, because when you have connected the apparatus, when you have properly fixed in the switches, you have properly plugged in the circuit and the wires are intact, and then you have switched on the circuit, electric field will be set up. That is what you have studied in the last lesson. Charges are present, charges will set up electric field. So under the influence of that electric field, right, due to that application of electric field, or you can say due to that connection of circuit, velocity, that velocity with which the electrons are moving towards the positive terminal, because obviously they'll not be moving towards the negative terminal. Electrons and negative terminal will get repelled. So electrons do move towards the positive terminal only. This actual movement of electrons and all you have in semiconductors also in your book too. So in anyways, here the electrons will be drifting towards the positive terminal with a certain velocity. So the average velocity of all the electrons, this is known as drift velocity. If I ask what is the velocity of electrons moving within a wire, you will tell me that drift velocity. Because it's impossible to tell the velocity of each and every electron. Had there been one or two electrons, we would have mentioned, but since there are so many electrons, it is difficult. For example, even this example, you can take if someone asks me, what is the score of this class? Suppose 20 marks test was conducted, what is the score of this class? So will all of you be getting the same score? Will all you be, let's say 18 on 20. Will all of you be getting 18 on 20? No. Someone will get 15 on 20, someone will get 19 on 20, someone will get 18 on 20, like this. So everyone will have a different score. But if someone asks me what is the value, what is the score of your class? So I'll tell the average score. I'll take every student's average. I'll take Austin's, Humam, Shahid, every student's marks individually. I'll take the average divided by the total number of students. This is how I take the average. How you take the average? Take the marks. I'll add Shahid mark, Humam's marks, Austin marks, Rabia's marks, Sarif marks, like this. I'll add Shavez's marks and then I'll divide it by the number of students, right? If I divide it by number of students, that will give me the average score for the class, though you all had obtained a different score. So that's it. That is what is drift velocity in terms of velocity and in terms of electron. Now, derivation is a little lengthy. Usually the derivation of drift velocity, usually it is not given, but in your school exam, more than board examination, you have this question in your school exam, the internal exams which will be going throughout. So there you can witness this question. So how will you calculate average velocity? Let's say initial velocity is U1, final velocity is V1. So average thermal velocity, U1 plus U2 plus U3 plus U4 plus U5, n number of electrons are present. So up till UN you will add and divide it by n. What are you? You are the thermal velocities. Thermal velocities basically means the initial velocities. Because when we start off with a circuit, there is heat production. That's why we call this as thermal velocity. But do not get confused. Just take it as in your exam mention average thermal velocity, but just consider for yourself, just consider it as initial velocity. Fine. So U1 plus U2, this you have obtained. Now, this is the definition of drift velocity. See, F is equal to ma, right? Force is equal to mass into acceleration. So acceleration will be force divided by mass. acceleration should be, see, force in terms of electronic charge, in terms of electric field. Remember, formula of force is also QE. QE, right? Charge multiplied by electric field. So what is the charge here? Electron. We are totally talking about the electrons right now. Someone asking something?
Yes, this drift velocity is the all electrons are moving towards positive, so this is known as drift velocity.
Yes, yes. See, actually, you do not have one particular drift velocity. It's like every electron will be having its velocity, its own velocity. One electron will be moving with, let's say, 3 meters per second. Another electron is moving with 5 meters per second. Another is moving with 2 meters per second. But when you take the average of all the velocities, when you calculate the average, like 3 plus 2 plus 5 divided by 3, the way you calculate normal average in maths, the way you use it, that velocity, that average velocity, which will be depicting the velocity for every electron. Suppose in that example class and Mark's example take, suppose if I tell someone that the average score of the class is 18. If I say average score of the class is 18, that doesn't mean every student has obtained 18. That means around 18, all of you have obtained. That's why the approximate, so someone must have obtained 19, someone must have obtained 17, 16, 16, 17, 18, 19, like this range. So average came out to be 18. This is what is the concept of drift velocity. Drift velocity also, it's the average velocity, which is depicting for every electron. But the problem here is, see, average you can calculate. If you people are there are 8 students in this class, right? So I can calculate the marks and average value for this class because 8 students are only present. But electrons are not present in the amount you people are present. Electrons are infinite within a conductor, within a wire when the conduction occurs. That's why we have a separate formula for it, which we are deriving right now. Otherwise, you can directly calculate it, take the average of all the values. Right, that's why we have a particular formula which we are deriving. Clear, Chavez?
Yes, sir.
Okay. So F is equal to QE. So charge is electronic charge, electric field E, and M is the mass of electron. So what is the acceleration? E by M. This has a significance. We'll be using this. This is an important thing which we have. Let's save it for a while. Now, see, when 2 electrons collide, electrons not only collide among themselves, they collide with the walls of container which they are moving, they collide with the positive ions which are present, they collide with the negative ions which are present, like this they collide. So when the electrons are actually colliding, during that real collision, no, the electron momentarily stops and then begins the next collision. So when this process occurs, when the electrons have stopped, they are resting. This is known as relaxation time. It's actually the time only, but we call it as relaxation time because right now electrons are not in motion. So let's say tau 1, we represent it through tau. This will also be mentioned you in the question, and this has a significance. So final velocities of all the electrons. Acceleration we have seen. V is equal to U plus AT. This equation you must have studied in your class 11. These are uniformly, this is one of the uniformly accelerated equation of motion. Accelerated equation of motion. This is final velocity is equal to initial velocity plus acceleration multiplied by time. Fine. V is equal to U plus AT. Now, what is the final velocity for one electron? Let's say the first electron. If I talk about the first electron, V1 is equal to U1 plus A tau 1. Initial final velocity of first electron is equal to initial velocity of first electron plus acceleration multiplied by the time, right? Then when I talk about the second electron, just a second. See, when I'm talking about the second electron, so final velocity of second electron is equal to initial velocity of second electron plus acceleration into relaxation time. Then third electron, V3 is equal to U3 plus A tau 3. Fourth electron, V4 is equal to U4 plus A tau 4. Like this. This will keep on moving. Every electron will be having its final velocity, right? Every electron is having its initial velocity. It will be having its final velocity as well. This will be the equation for all. So we are not considering these initial velocities as the drift velocity. These are actually the final velocities, because when you have connected your wire in this circuit, right? At that time, the charges were at rest. Charges were initially at rest. It was you who have connected the circuits, and then further the charges have started their motion. So initially they are at rest. That's why all the initial velocities will be 0. We are talking about the average of final velocities, which gives you the drift velocity. So here also, we'll calculate the average of all these velocities. Drift velocity will be V1 plus V2 plus V3 plus V4, V5 up till Vn, n number of charges which are present, their velocity is divided by n. Now see, what will drift velocity? Put the value of V1. What have we studied? U1 plus A tau 1 plus V2, U2 plus A tau 2, V3, U3 plus A tau 3, up till, just keep on adding them up till Un plus A tau n, because acceleration we have seen that was same for everything, divided by n also. 1n is also there, divided by n. Let's do one thing. Let's bring initial velocities together and the term A tau together, right? These terms I'm bringing it together. So U1 plus U2 plus U3 up till Un divided by n. This I have kept it together, plus acceleration tau 1, tau 2, tau 3 up till tau n. This term I have kept it together. That doesn't make a difference, right? This doesn't make a difference over here, because if I write this together, ultimately this would be getting added with this. This would be getting added. It's just the same. Why have I done this? It's that, firstly, all the initial velocities will become 0. This is actually this entire term. This becomes 0. Why? See, this entire term is 0 because all the electrons were initially at rest. Average thermal velocity is 0. There is no initial velocity. We are right now talking about only the final velocities which are present. And average relaxation time, no, instead of writing this entire term tau 1 plus tau 2 plus up till tau n divided by n, this is relaxation time. I have taken the average of relaxation time. This is average relaxation time. I am depicting it through just single tau. So what is drift velocity? Acceleration. This term becomes 0. Acceleration into this entire term becomes just tau. That is average of relaxation time. Because in the questions also, in the exam, you will get average relaxation time, not individual relaxation times will be mentioned. And what was the formula of acceleration we had obtained here? E by m, right? Small e into capital E by m. So what is the formula of drift velocity? E, capital E, tau divided by m. This is the formula of drift velocity. What are each term in this? This is the drift velocity. This is the drift velocity. E is the electronic charge. This is the electronic charge, which is one electronic charge, 1.6 into 10 to the power minus 19 coulomb, right? This E is the electric field under the application of which the charges have begun their motion. Tau is average relaxation time. This is average relaxation time. SI unit is in seconds only. This is normal. Just consider it as a normal time which you take, average relaxation time. M, I have been repeating this in the last class also. Some students had their extra class for current electricity. That time I had also repeated, and this term. M is not the mass of the conductor in which the charges are flowing. Many students get confused. This is mass of electron. This is mass of electron, which is 9.1 into 10 to the power minus 31 kgs. This is the mass of one electron, ME, which we write. One more thing. We put a negative sign in the formula. Now, what is the negative sign depicting? This negative sign we put. That negative sign only shows that drift velocity's direction is opposite to the direction of electric field. That's why we put a negative sign. So this negative sign basically shows that drift velocity's direction is opposite to that of electric field. That's it. This is opposite to that of electric field. That's why we put it. And this relation you will be having in your semiconductors. You have it in detail regarding the relation between temperature and drift velocity. Always remember. See, when temperature increases, average relaxation time decreases. See, if this quantity decreases, this will also decrease, right? If temperature, same thing, just opposite to it. If temperature decreases, tau increases and drift velocity also increases. These are just points which you should remember just in case they come. One more derivation is there. This derivation is not very, very important for all of you. Definition you should know, and this formula also you should know. The next derivation, this relation between electric current and drift velocity, this is very important. This we'll discuss, but by the time you note down this entire derivation. This can come in school exams, this can come in final board exam also, it can come, but it usually comes less. The next derivation comes more. temperature and drift velocity are related because of time. See, when you increase the temperature, the kinetic energy between the electrons increases. And when the kinetic electron energy between the electrons increases, that leads to more thermal conduction. Thermal conductivity increases. So because of that, the electrons move rapidly. So drift velocity decreases. Relaxation time is also reduced because the electrons don't wait now. They quickly collide as the temperature increases. This is morely because of kinetic energy.
I can just scroll up. Yes, sir. Yeah.
Done class till here? Okay. See one small derivation. See relation between current and drift velocity. So this formula is also very helpful, and this derivation is very important. In your 3 marks also it comes. See, electrons are present, electrons are moving within the conductor. The length of the conductor is A, area of length of conductor is L, area of cross section is A. Vd is the drift velocity, N is the number density, means number of electrons that are crossing a unit area. So if the distance is L, speed is drift velocity. So how do we write the time? Time becomes C, speed is equal to distance by time. So time will be distance divided by speed. This is our one equation, value of time. And what is charge? Charge is equal to any, Q is equal to any from quantization of charges, right? So that is for a single area. When you want to find it out through across the entire conductor, what we'll do? We'll multiply it by the volume, right? So what is the volume? Here the volume is area into the thickness, area of the cross section multiplied by the thickness or the length. So volume becomes area multiplied by length. So total amount of charges, total number of charges will become NE into AL. This is one more equation which you have, out of which AL is volume. Now coming back to the formula of current, what have we studied? Yes.
Q is equal to N is for a single charge.
The Q is equal to NEC. Q is equal to NE. This is the amount of charge. This is, see, when we are talking Q is equal to NE, Q is still the amount of charge that is present in a unit. Here we want to find out throughout the length of conductor. So because length of wires are not definite, and here when we are just taking Q is equal to NE, NE means that you're taking the charge in N number, N as an integral of electrons or charges. But see, still here what happens is charges amount is fixed within a segment. You have number of electrons which are present in 1 coulomb of charge in particular amount of coulomb. But what about the amount of charges which are present? Amount of electrons you can determine with this formula. But if I want to find out throughout the entire segment, until and unless I multiply it with the volume, I won't get the amount of charge that is distributed. So for the distribution we are seeing, otherwise Q is equal to NE was sufficient by itself. Fine, here we want to find out throughout the volume. Now coming to the formula, I is equal to Q by T. Charge is NEAL, and time we have calculated L divided by drift velocity. Drift velocity will go up, LL will get cancelled. Formula becomes NEAVD. This is a very important formula. I have initially written also. N is number density, E is electronic charge, A is area, and VD is the drift velocity. One thing class, when you look at this formula, this I had mentioned earlier also, when you look at this formula, it appears that current is also directly proportional to drift velocity. This seems, and current is directly proportional to area of the cross section. This is what we can conclude from this. But see, this is not true. Let me give you an example over here. Check this conductor. This is having a narrow end here. Area is A1, current is I1, drift velocity is VD1. This is a broader end, wider end. I2 is the current, A2 is the area, VD is the drift velocity, right? So current is actually independent of area of cross section, because whatever amount of charges come, those are only exact amount of charges which leave. So that doesn't depend upon area. If 5 coulomb is entering, 5 coulomb will leave, whether you make the area narrower or you make the area wider. So current is independent. In this case, I1 is equal to I2, though A2 is greater than A1. But your drift velocity is inversely proportional to area of cross section. These can come in your reasoning questions, 1 markers which you have. So if A2 is greater than A1, drift velocity 1 will be greater than drift velocity 2. It is inversely proportional. All right, quickly note down this part as well and mark this as important and revise this. Drift velocity, yes. Drift velocity is directly proportional to current. Drift velocity is, when we are talking about drift velocity, that is directly proportional to current. But if we are talking about area of cross section, that is independent.